Welcome! In this lesson, we will dive into deep learning, one of the most powerful subsets of machine learning. Deep learning models mimic the way humans think, using artificial neural networks to solve complex problems like image recognition, speech processing, and more. Let's explore the basic principles behind deep learning. What is deep learning? Deep learning is inspired by the human brain and uses neural networks to process and learn from vast amounts of data. It allows models to automatically discover patterns, make predictions, and improve themselves with more data and experience. Key idea: just like our brain has neurons that work together to process information, deep learning models have layers of interconnected neurons, also called nodes, that process data and learn from it. Neural networks. A neural network has layers of neurons. Input. Layer receives data. Hidden layers process data and extract patterns. Output layer produces the final prediction. Neurons apply weights, process inputs through activation functions, and pass data forward. More layers make a network deep, leading to deep learning. Key components of deep learning activation functions introduce nonlinearity, helping models learn complex patterns. Example: ReLU speeds up training. Optimization adjusts network weights to minimize errors. Example: Atom Optimizer improves performance on large datasets. Loss function measures prediction error. Example: Cross-entropy loss is used for classification tasks. Backpropagation updates weights by propagating errors backward, refining the model through training. Building and training a neural network. Let's look at an example of building a deep learning model in Python, using Keras, a popular deep learning framework. Creating the model, compiling the model, training the model, evaluating the model. Key techniques in deep learning. Dropout prevents overfitting by randomly deactivating neurons during training. Example: model.add, dropout 0.5. Convolutional neural networks, CNNs. Process image data by extracting features like edges and textures. Recurrent neural networks, RNNs, handle sequential data by retaining information from previous steps, useful for time series and language processing. Real-world applications of deep learning image recognition uses CNNs for tasks like facial recognition and object detection. Speech recognition powers virtual assistants like Siri and Alexa to understand speech. Autonomous vehicles rely on deep learning for object detection, path planning, and decision-making. Medical diagnostics aids doctors by analyzing medical images, e.g., X-rays, and predicting patient outcomes. In this lesson, we covered the basics of deep learning, including neural networks, activation functions, loss functions, and key techniques such as dropout. We also explored how deep learning is used in real-world applications like image and speech recognition. As we move forward, you'll learn how to implement deep learning models and train them to solve various AI problems. Stay tuned for the next lesson, where we explore deep learning in more detail.